Welcome back to Forbidden Knowledge News. I'm your host, Chris Matthew. Tonight I want to welcome Prasad. He is working with the world's first quantum computers in order to help build the infrastructure that will support the next decade's worth of quantum technologies. His goal is to save humanity hundreds of billions of research hours in developing the next generation of photovoltaics, superconductors, and metamaterials. In his spare time, he advises several blockchain startups focused on healthcare applications. He was named one of Toronto's top 20 under 20 in 2015. He has given talks on many cutting-edge technologies, including the intersection of AI with blockchain and healthcare, as well as quantum computing. And he has also been researching the UFO and UAP phenomenon. Deep, welcome. How you doing tonight?
Thank you. I'm doing amazing. It's been a nice, productive day, so I can't complain.
Very good. Well, welcome. Thank you for taking the time to do this. There's a lot we can talk about, and there is so much that we don't understand about the nature of our own reality. But as we move into the future and our technology continues to advance in these extraordinary ways, including understanding and creating applications for quantum computing, to me, it seems the closer we can get to understanding these questions about the nature of our own reality, and even if there is life outside our planet. And, you know, what are these things that are occurring in our skies? What are these objects that can move at incredible speeds, these anomalous lights, and the craft that no one can seem to understand completely? You know, we need to understand what's going on there. And I think that this whole world of quantum computing and quantum physics can help us understand all that as well. First, tonight, I'd like to start with a little bit more about yourself. Tell us more about your background and what got you started into your research into the UFOs, but more importantly, what got you into the world of quantum physics?
Sure. So I've always been interested in a wide variety of fields, like even as I was doing my undergrad in engineering. I, for example, took the Canada's first blockchain course when it was accredited. And I was also there when AI started picking up. So a lot of people might not realize, but the way that we use machine learning and AI as we refer to it today, we generally mean neural networks. That's the reason why it's so popular, is because our neural networks took off. So there were primitive forms of machine learning before this. And that happened around 2012. And then between 2012 to 2015, it was still somewhat of an unknown. It was still just starting to pick up in the tech circles that, hey, look, this new machine learning technique is actually useful for something. So I've always been sort of like, you know, into whatever is at the current, I guess, furthest edge of knowledge that humanity has, right? So what is it that we're currently at the forefront of? And so then I started near the end of my engineering degree, about a year before, I became very obsessed with quantum mechanics. For whatever reason, it really dawned on me some of the experiments that had happened beyond just the double slit experiment. There was a quantum eraser experiment, the fact that we had done what's called Bell test inequalities, and we had violated them in the labs. So yeah, eventually what I realized was that I wanted to get into quantum mechanics as a career, but as a career, it doesn't really pay much. So, and at the same time, I had this tech background. So I met somebody who's essentially one of the world's top quantum computing experts, and he recommended that I apply to this program that he had lectured at the year before. And so this program was the world's first quantum computing incubator. They would, for the first 2 to 3 months, teach you the fundamentals of quantum information science, quantum mechanics, quantum computing, and how it intersects with machine learning. So I got into that program after my university ended, and I started a company that started out of that program. And since then, the rest is kind of history. But yeah, the reason why I got interested in quantum physics is because it's it's such a it truly is the edge of what we know about reality. So that's where our next, fundamental answers will come from. So it's worth knowing. And it's just, amazing from a philosophy standpoint that it's even true.
You just recently started getting into the UFO research, right?
Yeah, exactly. Very recently. So I would say just about a year ago, I really stepped into this field. I had two phases of interest. One was when I was like early on as a sort of child for a couple of years, and then eventually it died off, and then it started off again just over a year ago, where I started like researching more into the whole Pentagon UFO situation. I started researching everything about ufology as a result. Like I realized that there might actually be something to this. So yeah.
So let's start out with a little bit more about quantum computing. I really don't know much. I was terrible at math. So
Okay.
let's start out. What is the difference versus quantum computing versus classical binary computing, and quantum physics versus regular physics?
Sure. So let's start with the quantum. Let's start with the quantum physics versus regular physics first, because then it makes answering the computing part easier. So with classical physics, the whole world follows classical physics in the sense that the world that we see, the macroscopic world, that is all classical. So general relativity, Newtonian mechanics, these are all classical physics. And so they're really good at describing large bodies. And so a large body could be you and I, it could be a laptop, right? There's billions and trillions of atoms, or planets, even much more than a few trillion atoms. Then there is the world of quantum physics, where they describe the physics of just one or two or small numbers of particles at a time, because they follow different rules than when you have a bunch of different particles clumped together. So for whatever reason, we found that the world behaves quantum mechanically when you look deep enough, when you look under a microscope, and you really magnify everything, right? And you see that, okay, fundamentally every subatomic particle, photons, electrons, you name it, they all behave based on the rules of quantum mechanics. So that's the differentiation. And there's different things that you can do in quantum mechanics that you can't do in the classical world. And so that's why it's so hard for us to understand all the weird things about quantum mechanics, because it's not intuitive. Like, we grew up in a classical world, right? I only see a classical version of you. So it doesn't make sense for me, for example, to assume that any object can somehow move through a wall without breaking it, right? But in quantum mechanics, this is possible through quantum tunneling. Like, it really does happen, where you'll have an electron and it can actually tunnel through a wall, which is amazing.
And as far as the computing aspect, what is the difference between, quantum computing and classical binary?
Sure. So now now we have classical computers, which is every computer to ever exist today, right? Other than quantum computers. And so classical computers, they are basically saying that we can only have a finite number of each bit that represents my computations, all my computational power. The fundamental units of logic that I'm using will follow classical physics rules. So classical physics will say that this thing can only exist as one version of itself. Whereas with a quantum computer, the fundamental information follows the rules of quantum mechanics. So your qubits can undergo quantum tunneling. Your qubits can be entangled together and behave as one. And you can sort of hidden in the background. So what quantum computers do is do what classical computers do, in the sense that they try to compute information using some fundamental information carrier. In this case, it's quantum bits rather than classical. And yeah, we're just trying to leverage quantum effects in quantum information science.
And what are qubits?
So qubits are the base representation of information for your system. So I'll give you a very pragmatic example. Let's just say, for the sake of the argument, my qubit represents a heads or a tail. So if my qubit, if I measure it in the one basis, so if I measure it as, let's say, spin up, I'll equate that as a heads. And if I measure as 0, it's a tails. So using that qubit, I can start making relationships with other qubits and then encode problems onto them and then solve them using quantum circuits. So if you look at the classical computer right now and how that's set up, you're starting with classical bits. Like, let's say I want to add 10 plus 12. I'll encode 10 and 12 into bits, and then I'll make a classical circuit on it, like made of logic gates. So this is how classical computers will then will calculate the answer, 10 plus 12. Because what they'll do is they'll take the classical bits that represent 10 plus 12, like 10 and number 12, and then they'll put it through the adder circuit. Then the adder circuit will give out a bunch of different bits, and those different bits will be my answer, which will be 22. Quantum computing is the exact same thing. Now you have qubits and you have quantum circuits rather than classical bits and classical circuits. And you'll have quantum bits as your output. And in those quantum bits are your answers.
Now, earlier I heard you mention quantum tunneling. Can you also explain what that is?
Yeah, absolutely. So quantum tunneling is the fact that you can have physical particles tunnel through walls because of Heisenberg's uncertainty principle. What ends up happening, plus the fact that the entire path of the particle is probabilistic. So what happens is that you always have some chance once you're near the wall, for example, for that particle to tunnel through. So if you think about the classical physics world, where, like I said, everything we see and measure is classical, right? So if I throw a ball at the wall right now and it'll bounce back. And so therefore it's following classical physics. Well, it's following classical physics because, yeah, we live in a classical world as macroscopic creatures. But that being said, if I miniaturize myself down to the size of a particle, let's say, and I threw my ball again, we can expect with some probability that that ball might just go straight through the wall as if it was never there, like a ghost, you can say. So that's quantum tunneling.
Wow, that's amazing. So there is, I guess you're saying there's always some chance, no matter how small, that could actually occur in reality.
Exactly. And not just it could occur, it does occur. So in transistor design, our transistors went from very large, right, like about the size of my hand, to the point where they're a couple atoms big. And here's the problem: when your transistor is only a few atoms in size, quantum effects start taking over. So now you have electrons literally tunneling through your transistor walls, which you don't want happening. So, yeah.
Now, as human beings at the quantum level, would you say that we are still physical, or do we become, I guess, in a way, non-physical?
Yeah, it's hard. So suddenly the idea of physicality and non-physicality itself start to break down, because so it's like you've touched on a very fundamental debate in quantum mechanics, which is, how do we interpret the wave function? So there are people who, I believe they're called anti-realists, and they say that the wave function in all of reality is purely an illusion. So when you make a measurement on a quantum mechanical system, all the measurements you've gotten are just illusions. There's nothing more than the measurement itself, and then that's it. Whereas with other physicists, they disagree, and they take the wave function as a more literal sense, so that we live somewhere on this wave function. And so, yeah, essentially, when it comes to, are we physical or non-physical from a quantum sense, it depends on how you define your own barrier of reality. So like would you consider, for example, I'll make it more clear. Like, so consider this. If we were to take the most strict definition of quantum mechanics, then we would say that everything we measure is the only thing that exists that we can measure. That is the only thing we can say about nature. So that means, like, for example, right now, you as you look at your screen and as I look at mine, we're both making measurements on our respective devices. We're making measurements and we're seeing each other as a result. So what you could then say or ask yourself is, if you consider that real, then, and you consider the proposition of quantum mechanics to be true, then let's move towards dreams for a second. So in the dream world, what you measure is the only thing that exists. But that's weird, because in your dream world, the only thing you're measuring are your dream characters and your dreams. So according to quantum mechanics, if you're going to follow it rigorously, you have to admit that that's the only reality that exists at that time, which is strange, right? Because most people would say that that doesn't count as a physical reality. So, yeah.
Oh, that is fascinating. Would you say that quantum physics could help us understand the world of the metaphysical, or paranormal phenomena?
Yeah, certainly. I think it'll help us, especially with, like, let's say telepathy, right? A lot of people will cite quantum entanglement as it might be, it could be part of the scheme. So one thing that we can't do right now, we can create entangled particles, and we can make quantum communication networks. But there's always a part in the quantum communication and quantum teleportation scheme that we have, where you have to send some classical information, which is therefore limited by the speed of light. So if you could somehow overcome that, you could actually have some kind of pure telepathy, where the information is going straight back and forth to the receiver and the sender, and there isn't some middle step. Right now, though, we don't know how you could do that, but who knows what the future holds. There's also the idea of consciousness and the observer, and of course that does play a big role in quantum mechanics as well, in terms of the fundamentals. We still don't, in QM, we don't know, we don't agree on what an observer is. We don't have an agreed definition on what it means to even make a measurement in the first place. So it's very similar to some of the metaphysics questions.
Yeah, and I find that very interesting. I believe that more fields of research should come together to
Yeah.
understand this. We should come together with quantum physics, with consciousness researchers. Just to understand how it all links together. Wouldn't you say?
Yeah, absolutely. Yeah, you're totally right about that. It actually reminds me of a saying. I think Richard Feynman said it first, but I'm sure other people have too. He said that nature doesn't know or care that we differentiate between geography and physics and biology and sociology, right? It just does its thing. So just like, yeah, going on that logic, and as you said, we should not differentiate between, let's say, the phenomena and quantum mechanics and philosophy.
What are your thoughts on the theory that there are multiple realities, multiple different versions of us occurring at the same time?
It's inevitable, to be honest. Like, I feel like, if you like, just going back to the wave function, there's there is something to be said about the fact that there's all this extra information that is stored between two entangled particles, or any n system of particles, where we have no way of directly accessing that information. Like, where does that information get stored, right? Who is doing that bookkeeping? If you look at the physical interpretation of the wave function, and say we make a measurement and we collapse it, um, that almost directly means that the rest of the wave function exists somewhere else. So it's very hard to say that there isn't some sort of multiverse. out there. There must be something. And if it's not the multiverse, it's almost like it would have to be even more absurd than what we currently imagine it to be.
And would you think there is just limitless versions? And if so, is it just our planet, or is it the entire universe that falls under this? It's so it goes so deep. I'm wondering, how does that work?
Yeah, it does, and it can get really wonky. So here's the thing: do you know about how we have different infinities? Just real quick.
Go ahead. No, explain.
Okay, so let's take the entire set of numbers from 0 to positive infinity, right? So that's still smaller than negative infinity all the way to positive infinity. And that set is still smaller than 0 to all the numbers between 0 to 1, right? So 0 0.1, 0 0.12, 0 0.1211. So those numbers, those decimal numbers, that set is still even a larger infinite. Then there's the infinite that you'll find in the irrationals. So the digit pi, for example, 3.1415, whatever, that whole thing, theoretically, because we think that it's infinite, then inside that sequence of numbers would have your social security number, your birthday. It could even have in binary digits your entire life spelled out. Every single thing you've ever done and talked about and thought about, right, would be encoded in those infinite sequences. So there's different sizes of infinites. And that matters in the idea of the multiverse for this reason, because let's say there is an infinite number of multiverses, then are there an infinite number of humans that are equally as infinite as the multiverse? Or are there, layover remaining multiverses that's not inhabited at all? And if it is the case that there is an infinite number of multiverses and an equal number of infinite people to live in them, then why isn't it that eventually an infinite number of people aren't jumping into my doorway right now or going through your room? Because eventually one of them or all of them will figure out some sort of multiverse travel, right? And if they can't do that, then why is it that there's millions of versions of us in the first place? That's kind of freaky.
That is crazy. Wow. I'm going to be thinking about that one all night.
Awesome.
Man. All right. So another theory that comes up more and more often, and it's quite disturbing to me, is the simulation theory, the theory that everything is just some sort of computer simulation. What are your thoughts on that?
Yeah. So I think the simulation is definitely our best approximation to what's going on. But just like when we built our first mechanical machines, we thought that the entire universe was a big mechanical machine when we first built those. So, and before that, before we had any idea of any of that, we would say that the whole world is built on a turtle or some animal, right? So so I think that now that we have computers, we think that we're onto something, but we're probably not. We might develop something even more advanced in couple hundred years and say the universe is actually this new advanced technology. So yeah, you see what I mean by it's our best approximation, but I don't think it's the answer.
And it just brings up so many other questions, like, does it run itself, or is there something controlling the simulation? Was it always there? There's so many things that could go along with that.
Exactly. And it all touches back to the fundamental paradox that, and I ask everyone to think about this, which is, why does anything exist at all in the first place? Like, how is this even possible that we're having this conversation when there should be nothing forcing anything into existence, right? It's not needed. It's all this extra matter, information, energy taking up some space, but of what? Of where, right? Like, where is this all happening?
Now, something else I'd like to you to help me understand is dark matter and dark energy. Explain a little bit about each, and what are the differences, and how do they affect our planet in the whole scheme of things?
Sure. So we expected. Let's start with dark energy first. We expected the universe to have a specific expansion rate that we were going to measure, and it would, sort of empirically follow what our models were theorizing. But we found that the universe is actually expanding much faster and accelerating in its expansion than we expected it to. So the analogy, if you want to think about this physically, why this might be weird is this. Let's say I'm playing baseball and I hit the baseball. Eventually the ball will fall down, right? I expect it to hit the field somewhere. That's what we were expecting the universe to be doing. But instead what we found out is that it's the equivalent of us hitting the baseball, and then the ball just keeps flying out of the stadium. And it keeps flying faster and faster until it leaves orbit. And it just keeps going even faster and faster. Wouldn't that be weird? But that's what we're dealing with. So that's dark energy, is the fact that we have all this extra energy fueling our expansion. So that coupled with dark matter, basically, as you can imagine, makes up the majority of the observed universe, right? We're only a very small fraction because of this. So dark matter is kind of the opposite. So dark matter is the fact that we saw that many of these galaxies should be farther away from each other than they really are. It's like they're being galaxies, star systems, you name it. It's like they're being dragged together and clumped together by invisible matter that we don't see. So that's why we call it dark matter. It's not like we actually know it is matter for sure, but it has a gravitational interaction of some kind. So
what are the I guess the main interactions that these forces have with our planet?
That's the weird thing. So it's only gravity. We can't even directly, dark energy is even harder to detect than dark matter, in the sense that dark matter we can sort of infer easier. We can measure, okay, given the mass of this galaxy, what should the normal attraction be with the other galaxies around it, right? You can just use even Newton's law of gravitation to figure that out. But with, let's say, dark energy for a second, we can't touch it, we can't smell it, we can't feel it, hear it, we can't put any sensors that we've ever built to detect it. So same with dark matter too, mind you. Dark matter, it's only a little bit better than dark energy because of its gravitational effect on nearby bodies. That we can at least measure that. But yeah, we don't know what any of these things taste or look like, for as trivial as that might sound.
Very interesting. Now, can you also explain the difference between quantum gravity and regular gravity?
Yeah, absolutely. So regular gravity is basically gravity as we define it under the Einsteinian physics, so relativistic physics, even Newtonian physics. Gravity there is the gravity that describes classical objects. So the gravity between two balls, or the gravity between two big bodies floating in space. That's normal gravity. Quantum gravity is essentially the quantized version of gravity. So it's trying to basically treat quantum mechanics and gravity and unify them. So it's one of our most leading theories in trying to unify the two fields of physics. Quantum gravity has had some success in its predictions. So yeah.
Now, I'm wondering if you've ever done any research into the Mandela Effect. This is an interesting phenomenon that's been occurring for the past few years. I am on the fence. I'm not sure about it. I'm wondering if it's just some sort of strange internet phenomenon, people misremembering things, but there are some pretty compelling bits that make me kind of wonder about it. What are your thoughts on it?
Yeah, so I find the idea of the Mandela effect being true disturbing, at its absolute core. If it is true, then that's extremely messed up, because it's more evidence than supporting evidence for the simulation theory, if anything, or simulation hypothesis. But so did you watch that video by any chance of a tech CEO? Talking about the Mandela effect?
No, I didn't.
Okay, so I'll send it to you.
No, wait. I think I do. No, I know what you're talking about now. Now I remember.
Awesome.
Yes, I did see it. Okay.
Awesome. Yeah, that got me thinking because before then I wasn't thinking about this at all. And I think this guy posted that video a couple months ago.
Yeah,
Um,
he was on Fade to Black as well. Now, yeah, it's all coming back. I know who you're talking about.
okay, yeah, right on, right on. So like I realized like some of those Mandela effects apply to me as well. Like for example, the Bernstein Bears. I distinctly remember EIN. It's no longer that, or like the Haas avocados. So, and I'm just like you. I'm on the fence too. Like, is this just my bad memory, and we're all kind of just fooling ourselves? You know, like these are just those little things that are like right there, but they're actually prosaic explanation. But it's hard to completely rule that or like say that, you know what I mean? So that being said, like let's assume that it is happening. Let's just for a second accept that it might be true. All that means then theoretically is that our reality is even more abstract than we thought it was. So like for example with Haas avocados, the CEO brought up a point where the history that he remembered was like completely different than the history that we have currently of how the Haas avocados were built and brought about. That means that you have two physical objects that are supposedly the same, two physical entities, which are avocados, but completely different histories. So the abstract information, the metadata that goes along with those avocados in that case are different. Uh, they're they're varied, right? So that's what I mean by the universe would have to be more abstract than we currently think it is.
So if this Mandela effect was actually occurring, if something actually caused a change in our reality, what would be something that would have caused it? Any theories on that?
Yeah, that's a. It depends on, I guess, if you believe in a creator or not. Like, if you think this is completely random, then there are explanations for that too. But and obviously, if you think that there's some sort of intelligence behind this, then that person, it gets weird because you would think that they would have figured out that we would figure out that this is happening. So it would, in any case, whether there is a creator or not, the Mandela effect would, if it's true, it would have to have been accounted for from the beginning of the creation of our universe. For some reason, it would have to have some sort of basic need, some reason to exist. So normally in physics, everything that we encounter, it exists and it behaves the way it does because of the principle of least action. So if I drop water, I know that the water will follow the path of least resistance. So what we could infer from that is that if we are having Mandela effects, then for some reason that takes the path of least resistance. And from what and to what, I don't know.
What about time travel? What are the possibilities? And something interesting, I was speaking with someone that is actually going to be at the conference with us, Dr. Bruce Goldberg, who
Oh, awesome.
believes that some of these UFOs may actually be time travelers coming back to kind of examine us. So, what are your thoughts on time travel and its possibilities?
Yeah, so time travels, I think, is also another inevitable thing that we end up figuring out and doing as well. So we're already time travelers, right? We're moving into the future. And all of us, just by moving around, have a slightly different experience of time. That's already guaranteed. So all we need to do is maximize that differential. So um, what I think, like for example, take UAPs. So a lot of scientists still don't believe that, let's say, faster than light travel is possible. But it's hard for me to both accept that UAPs exist and might not be human driven, and also that faster than light travel is not possible. Like you can't have all three at the same time. So I would say that just off right there, when you travel faster than light, you're breaking causality. So if you break causality, I imagine the universe does something like some sort of patchwork, some sort of way to make sure that no paradoxes are introduced. So what I wonder with time traveling is what kind of paradoxes are being introduced and how does the universe patch itself. But I do think that it's inevitable that if you can have this kind of technology, then time travel tech is probably inevitable. I would almost say that basically any UAP we might see, maybe not a single one might be from our current time as we define.
What about the theory that, you know, as time is just all occurring simultaneously, past, present, and future?
Right. So that's the Bloch sphere theory. It's the idea that the entire universe can be described as a giant, you can say, a giant loaf of bread, and we're just moving through the loaf of bread. So that, I think, is it doesn't account for everything we see and observe in quantum mechanics, and same with the phenomena as well, the way that it behaves and what it can do. I don't think that time that we are moving through the sort of Bloch universe where everything that has happened already exists. I think it's more like it's a mix of both. So we live in a stochastic, undecided, random world.
You broke up there for whenever you were saying what you actually believe that the type of world we live in.
Sure. So yeah, I believe that we actually live in a both deterministic world and a stochastic, undecided world. So that's another thing about quantum mechanics that I found really interesting when I first started out, was the idea of an inherent randomness. So let's say that you created a device that measures the spin of an electron, and it can only be spin up or spin down in our case. Here's a crazy thing. It's like basically the electron, you'll always have a 50-50% chance of measuring up or down in your little device. So every time I throw an electron in there, you don't know whether it's up or down. But if it goes through the up hole, then you know that it was spin up. If it goes through the down, then yeah, you know that it was a spin down electron. The interesting thing about nature is that we have no model. We've never been able to successfully predict whether it will go up or whether it will go down. We can only know what the probabilities are of whether it will go up or down. But what nature does in the background, why it chooses one and not the other, it's beyond us. It's true random, which it's an absurd, I think, truth about the world. So when I think about the whole Bloch sphere thing, I realize that this is also true, that at its very basis, reality seems to have not made up its mind until literally the very last second, until you make a measurement.
Very interesting. Now, we all hear the fears and the theories that AI, you know, may one day take over humanity, and it's an extreme danger. And even Elon Musk warns against the dangers of AI. What are your thoughts on that? Do you think that AI is a threat to humanity?
Yes and no. So it is a more immediate threat based on, let's say, one example that Elon's brought up, and I completely agree with, is with drones, right? So you can now make very cheap facial processing algorithms and combine it with a drone and maybe attach a weapon to the drone. And now you have something that will, chase like Prasad or Chris whenever, they're pissed off, right? Like so you can already create that today, and it wouldn't be fun to deal with these kinds of devices or adversaries. But then there's also the long-term dangers, which is losing our own human identity, definitely losing our position as the apex predator. I mean, it's not like we are in the first place, like realistically, but we are currently in the mainstream society, right? That we consider ourselves as top of the food chain. Then you also have the idea of living next to almost an alien culture, because what happens when your AIs develop their own feelings, philosophies, societies? We are now living next to them, and what does that look like? And how do we make sure that the AIs that we develop now will blossom into good children, you can say, in the future?
And is this something, do you think, we should be concerned about immediately, or do you think it's something we should be concerned about for the next generation, that we just need to make sure that it doesn't happen now, that, so they don't take over the world?
Right. Yeah, I think that's a smarter idea, like doing it now so we can prevent anything from happening in the future. And I'll give you like a thought experiment. So it's called the stop button problem. It comes from a branch of philosophy and computer science. And this experiment, let's say you made a robot that its task is to bring you coffee at 7 p.m. every night. For whatever reason, you like coffee at 7 at night. And so and it's super intelligent. Let's say it's more intelligent than a human being. So it can reprogram itself whenever it needs to. If its reward is to give you coffee at 7 p.m., it will do anything it needs, anything it takes to give you that coffee. So let's say you decide that you don't want coffee the next day. Like you're just not in the mood. It won't care. It'll override that because it'll think you're trying to stop it from achieving its goal. So if it doesn't have context, right, it might even hurt you. Well, like even though it wanted to give you coffee, or you might be all the way in China and you'll see that it bursts through your door to come and give you coffee. So the stop button problem is, how do we teach the same ethics and context and social rules that we already intrinsically know? Because you can't just keep coding for each and single scenario that could go wrong, right? That would take forever. It would just be impossible. So the stop button problem still has no solution. We need a solution before we build these kinds of devices, these beings.
Yeah, and my biggest fear is, one day they just decide that humans aren't good for the planet, and they're just
Exactly.
gonna go ahead and clean us out there.
Right. Which I would be shocked, because it seems, and maybe we're all wrong, but it seems like the phenomena, not all of it is AI based. Some of it seems to be either post or some other kind of life form. So that might be what's in store for us too. We might not actually live in a world at any point where it's completely dominated by AI. It might be a very fast era in humanity. Like it won't last as long as we think.
What are your thoughts on transhumanism and the thought that we could one day possibly upload our consciousness to some sort of robot or device?
I love transhumanism. I really like the idea. I don't know if we'll ever see it in our lifetime where you have real transhumanists who can go sort of beyond like our initial biology. But I think in principle it's possible. So I forget which Dalai Lama it was, but one of them recently said that if you can construct a machine sufficiently complex enough, it can store the human consciousness, and then you could transfer it into it. So this is somebody like him saying that, right? And I completely agree in principle. Do you know I think it's the Thuzian ship paradox, where you reconstruct a ship, replacing one plank at a time, and at what point does that ship become a new ship entirely, right? Uh, do you know what I mean? Like, do you see where the paradox comes? So with consciousness, it's going to be the same thing. If we can figure out the solution to that paradox, the solution is positive, that as in our mind isn't a completely new mind as soon as we transfer it into the machine, then we're good to go. But if we find out that you've actually just killed yourself in the process and made a clone of yourself, that's a fail, right? So, but I do think in principle, we will one day do that. We will upload our minds to the computers, and it will be our initial selves.
And it just brings up it brings up so many questions along with it, as you know, is our consciousness, is that our soul going to be attached to it, or is it still
Exactly.
what makes us us? I mean, is this just going to be a copy of us? You know, are we going to lose our true essence? There's so many questions that go along with that, and I'm sure, you know, a lot of concerns for people as well.
Yeah, absolutely. Like, for example, what is personal identity, right? Is it the continuity of a person? Is it their memories? Every single thing we've ever thought of has had some sort of flaw in the answer. So, yeah, it's very strange why it's such a hard question to answer. And that's also what some people I've seen have theorized about the phenomena, is that they have a better understanding of what it means to be conscious, and what it means to be singular versus non. And I could see how an advanced civilization could take advantage of that for sure.
What are your thoughts on CERN? There's so many conspiracy theories and different rumors going around on the internet about what could possibly be going on at CERN. I've done a little research into it, but I still don't understand completely what they're doing there. I don't know if you've done any research into it and maybe could help us understand what's going on there at all at CERN.
Absolutely. So I took certain master classes in grade 11 and grade 12. So when I was 16 and 17, they I would go to UBC, so it's the University of British Columbia, where CERN would basically teach a select group of students how their software worked, how the data that CERN looks at works, and just everything really that we could know about particle physics, at least that they could teach us in a couple sittings. So I really got to get, and the beauty is that I got into these classes before they discovered the Higgs boson. So that was a really fun experience, because the Higgs boson is the God particle, right? It's the thing that gives everything mass. And so we thought that we had an idea that it would exist, right? Boson himself had predicted that it would exist, but it took a couple of decades until we could prove it. So that's what CERN's main thing was, that they discovered this thing. And all CERN does in the end of the day is it takes two particles, it speeds them up really fast in a circular-like fashion, and just smashes them against each other. And in that smash, all these tiny bits and pieces of particles will come out. And we measure those bits and pieces of particles because they're very exotic and they make up the initial particles. And so we try to find new physics in those little bits and pieces. And we try to calculate the angular momentums and see if there's some property or some new particles in the collision that comes out that we haven't seen before. So yeah, that's all CERN. That's all that CERN's really doing. It's just putting a bunch of energy into tiny little particles and hitting them really fast, and then measuring the output value. So the conspiracies, I feel, they don't have a strong basis. They need to be conspiracizing. I don't know what the word would be, about other facilities that are high energy facilities. Like I would say, Los Alamos is far more likely to contain some interesting projects than CERN.
Would you say there's any danger in what CERN's doing? Any danger that could possibly be catastrophic to the planet or anything like that?
Yeah, not even remotely. Like they can't make a black hole. They can't make anything that would kill us. They're not producing enough energy. In fact, we are better off thinking about the amount of kinetic energy, for example, that a Tic Tac has if it decided to ram itself into a city. That would be the equivalent of a nuclear explosion. So,
Now, I was listening a while back to a talk that Geordie Rose was giving,
nice.
and it was very interesting. Some of the terms he was throwing out there, like it was like an altar to an alien god.
Yep.
Things like it's like we're gonna be summoning the old ones. these interesting things that he would just kind of throw out there. It's very concerning at times, but what are your thoughts on the D wave and, you know, what Geordie Rose is actually talking about when he's talking about, you know, these things that we're going to be interacting with, these AIs are actually going to be aliens, and it's like summoning the old ones. What do you think he's meaning by this?
Yeah, I mean, that's a fair question. So I've seen Jordy in person. I've never talked to him because he's always surrounded by like a lot of people whenever he comes. But so Jordy's he's a great guy. He's a bit out there, but I think he's obviously onto something when he talks about the idea of the AI god, let's say, right? Like or an alter to an I think it's an alter to an AI god, right? Or is it an alien god?
That alien god, yeah.
Yeah, so and he equates aliens to AIs and says that AIs are kind of like aliens, right? And Elon Musk says the same exact thing, and that is true. Like they would have their own cultures, their own intuition, their own everything. So it would be very alien for all intents and purposes. So Rose likely sees what's coming in the future. Like he probably figures this is where we're headed. By the way, you might be interested to in this fact. Rose left D-Wave a while ago, I think a couple of years back. He now runs a company called Sanctuary.ai. And Sanctuary.ai, yeah, so Sanctuary.ai, they make androids. And the whole point is for these androids to have super empathy. And I think that's fascinating. Hopefully that works out. But as far as D-Wave goes, they're props on them for being the world's first quantum computing company, right? Like they made the first quantum computers and sold them commercially, and that's huge. They're now being surpassed by actual universal computation models. Like D-Wave only does specific computations. They don't do universal computations. Like your computer and my computer, it does universal computations. And that's what we want quantum computers to do in the end of the day. So those exist too. Google has built one, and Rigetti has built one, IBM, but they're very, very in their nascency. They've only taken baby steps for the most part.
Now, for the last half of the show, I want to talk about UFOs and UAP.
Great.
One of the things that fascinates me is throughout time, the phenomenon has changed. In the 50s, you know, it used to be airships or strange metallic saucers, and then later it became, you know, the saucers became more advanced, and now we're seeing light ships and plasma ships and these weird interdimensional things. What do you think it is about the phenomenon? It's like it can shapeshift based on human consciousness or the consciousness at the time period. What are your thoughts on that?
So I always wonder how much of it is like them shapeshifting and how much of it is our perception just being limited at the time, right? So how do we know that an airship, let's say in the early 1900s or late 1800s, wasn't a Tic Tac or some other cigar-shaped UFO, and they just didn't have that lexicon, those words, so they called it an airship. But really, it was the same thing we're seeing. So if it's true though that truly this phenomena is somehow warping itself to our expectations, what we can understand, then that's beautiful. It's very exciting because we can test it. And here's how. So like in the like according to, for example, Jacques Vallée, people were told that they were from a different continent during the airship's time, right? They would say we're from this continent, and then it moved on to planets, and then eventually moved into multi-dimensions. So when they moved to planets, that was about a decade or so after we actually sort of understood as a society that other planets outside the solar system even exist in the first place. So like and it was just around the time that astrophysics was really becoming popularized and we were going to the moon, et cetera, et cetera. So space was really in the public zeitgeist, and eventually what we could do to test this hypothesis is that, let's say we eventually discover the multiverse, we find definitive proof for it, and there's some sort of name we give it. or a name for all the multiverses that we find out there, then we should expect the phenomena to start identifying itself as being from this multiverse or that multiverse, if they behave as we expect it to.
Now, with some of these sightings, well, with most of these sightings, there's never any sound reported. Even with the more physical or metallic craft, there's usually never any sound. What does that indicate to you that when there's no sound associated with these sightings?
It means that it indicates that there's no traditional particle interaction that we're aware of. No sort of, let's say, electromagnetic and matter reaction or interaction that we're used to. So when I bounce a radar, when I hear something, like for example, what is a sound, right? A sound is just an oscillation in the medium that's around you. So if there's no oscillations being created, then that medium itself is not being perturbed, it's not being disturbed by the UAP or by its presence, but I can still see it. So my photons interact with the UAP, but nothing else seems to. And people have touched these things, right? Like in the Rendlesham case. So we know that we're not dealing with holograms here, yet somehow it's still able to exist physically, but it only interacts with the physical environment how it wants to, like on its own basis. So what that indicates to me is a very deep control of matter, an extremely expert level of science that we haven't yet attained, which is that we're constantly sort of building workarounds around nature, but it's as if nature works around the craft in these cases.
Now, when it comes to the speed that these craft are traveling at, it's phenomenal. But not only that, but you hear cases when they come in and they hit the water, they don't slow down. So,
Right.
talk a little bit about how they could be achieving these speeds and how they could be, achieving the phenomenon where they don't have to slow down when hitting the water.
So one way that the only way that I can think of where you can basically have transmedium travel to the max, right? That's what we're describing here, is if somehow you might be, and this is just a theory, if you can somehow quantize a very large body like a UAP. So where you can have almost mini quantum tunneling like effects. So imagine if I could somehow create quantum effects that apply to my entire ship rather than just tiny little particles, right? I somehow figure out how to do that. Then in theory, I could tunnel through the air and have no problem. I could tunnel through the water as if it's not even there. I'm sure there are pitfalls that I need to think about that you would have to design against, but those would be engineering problems. So yeah, in theory, that's one way of how I would see that happening.
How much of the phenomenon do you think is actually our military or military industrial complex craft, something like that?
At this point, it's probably like a high number. Like I would say 60 to 70% would be ours. But I mean like misidentifications. I don't mean like 60 to 70% of UAPs that have the 5 observables are ours. Like not even close. I would say 0% of those are actually ours.
Now, these ships, I don't think that they're probably traveling across the galaxy. They probably mastered some kind of wormhole technology or something like that, wouldn't you say?
Yeah, like well, it depends on if they're biological or not, I guess. So if their lifespans are short, then it wouldn't make any sense at all. I agree that they're traveling from here to some other planet. They would be dead. So there must be some, and the wormhole itself brings its own can of worms that are really interesting, because in order to create a traversable wormhole where you can have point-to-point travel, somebody had to have been there first to create that wormhole and connect it to the other one. So this network, that if there is one, it could be potentially millions of years old and still in use. Like the second we're dealing with wormhole technology, we're talking things that would have to be very, very ancient, at the least.
You think there are any other ways that they would be traveling these incredible distances in, short periods of time?
Through the faster than light method. Like obviously we haven't proven that that's physically possible yet, but I'm quite certain it is. I have a strong feeling anyways that at least some of these craft, they can cut through space-time like it's nothing.
Now, as far as To the Stars Academy,
Yeah.
it's very interesting. I don't know if I trust them. I'm always fascinated that they got this, former rock star, Tom DeLonge.
Yeah.
They're basically their spokesman for this. It's very interesting to me. I'm not sure if I trust the whole thing. I don't know if I trust the information coming out, but it's interesting. We've never had anything like this before. All the talk in the mainstream media, the integration of that with the military investigating metamaterials. It's
Right.
very interesting, the stuff that's going on right now. What are your thoughts on To the Stars Academy?
So yeah, I've mostly good thoughts about them, some like critiques, as with any other company. But like the mostly bad I'll say is that like it's the lack of transparency, right? It's the fact that they don't care at all about the public and about ufology for the most part. I don't think that's a good strategy at all. Like I do see why they might do that, but yeah, it's probably not ideal. The other thing is that like Tom DeLonge, while he's a great guy, like a good character, if they are serious about getting this message to the rest of the world in a serious manner, he should stop making so many jokes and so many exaggerations about this topic and what he's done. So like besides that, the good things they've done, like you said, like they've brought so much mainstream media attention. And had it not been for that mainstream attention, people like myself, Dr. Kevin Knuth, some other guys, we would not be here, like in ufology. So I give them props for that. Like I'll never forget that they, were big players there. But it's hard though to like. I thought that TTSA was disclosure. When I went to the SCU conference almost a year ago, I was convinced that yeah, this is it. But now I see that it's not. Like I do think that I get the feeling now that it's more like they are truly the Pentagon's response to knowing that the phenomena has increased its presence and incursions, and now they're kind of just like trying to uh, let's just say react to it, and rather than being proactive. Yeah.
And can you talk about some of these, at least what you know about these metamaterials? First of all, what are the claims behind it? What and what supposedly is making up these materials?
Sure. So the claim behind it is that specifically the only one we're told about in the public eye is the ones that they talk about anyways is the Linden Moulton Howe parts, right? So Linda's parts or Art's parts, they were purported to be made of only three elements: bismuth, magnesium, and zinc. And specifically, I believe it's bismuth plus magnesium zinc, like the compound. So what TTSA was claiming was that there's no bonding agent between the bismuth and the magnesium layers, and they're somehow bonded without any adhesive. That turned out to be wrong. From the scientists that I talked to, who spent over a year and a half like analyzing these materials, and also TTSA never published his results, even though this guy is a very very reputable scientist. Lots of publications, huge lab. They had no reason not to mention him, other than that it would make them look bad. But that being said, like So we found that there are more elements in it than those three that I just listed. There's also calcium, and I believe lead and some other elements too. So, and we found that based on the X-ray diffraction, like he found it, I realized it as well, is that like there is definitely some sort of adhesion. So it's not that there's no way for these two to be bonded like the layers. And another claim about it was that the metamaterial is a waveguide, or that it could be a waveguide. There's no proof for that at all. We haven't, it's never acted like a waveguide. So we can't even say that it is a metamaterial for now. Yet they've been calling it that the whole time. So
That's what I was going to say. It must be hard to analyze this, especially because you don't have any actual materials to compare it to, right?
right, exactly. There's no materials, there's no known functionality. For what it's worth, the compounds that it was made of didn't show up in any known database that we could find. But it also doesn't do anything. Like it literally doesn't do anything. This is why I keep saying that the idea of proving metamaterials is just a red herring. Like I realize it's a complete waste of time. It's making the community run in circles. But we're not going to prove alien life by any of this kind of stuff.
So is there any way, I guess, to prove that it is manufactured material that comes from off this planet?
There is. There still is. And there's only two ways that I can think of. One is if these materials achieve some sort of physical effect that we can't recreate, or that our physics doesn't predict. So, so something that Lou told me at the SU conference was that one of their parts, it accelerates an electron as it moves over the part. So that technically shouldn't be possible. You can't accelerate an electron without any external forces added to your system. It just breaks conservation of energy laws, and actually will eventually break causality, right? If you do to, let's say, a photon. So that's amazing. Like that would definitely be proof, that we're dealing with something much more beyond and advanced than what we have. The other way that I see it going is, or proving that it's CT based, is if you can literally find the craft that it came from and the bodies, and you just match the piece to it. So
do you think that we will be eventually able to learn anything that'll help us, with future developments, with our own, I guess, military?
the military certainly will learn a lot. The public, I don't think will learn anything. Like we might, if we're very, 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 very lucky, TTSA might say, we found that this was super anomalous, and that's it. And they've kind of already said that, right? But I don't think we're going to get much more than that. I think the military will get a lot out of it.
Now, there's a lot of tensions going on right now with everything going on in the Middle East. A lot of, fears of nuclear war. And we've all heard of the accounts in the past of these UFOs actually shutting down nuclear sites and things like that. Do you think if there was ever a genuine nuclear threat that they would actually intervene and shut these down?
Yes, 100%. In fact, I'm counting on it. Like, I actually believe that there's nothing to worry about. There were probably some sort of expensive science experiment that they don't want to ruin. So yeah, I think we'll be fine. Like we can stick to our guns. That doesn't have long-lasting impact on the environment, but radiation sure does.
Now, as a final thought, social media and the technology surrounding that is growing every day, but also, data collection, and it seems that it's becoming a little bit more invasive. And then we have now these deep fakes, a lot of concerning stuff that's coming along with this technology. What are your thoughts on the future of this, and how we could maybe correct some of these issues that we see starting to come up right now with this technology?
One thing that I think we should really get into is the idea of non-invasive biometric security. So, like, I'm not saying we should tag ourselves, right? We don't need implants, but we can. There are scanners that I know China is already trying these out. There are scanners which will scan your skin, so any part of your skin. And what I found out was that our skin has a unique identity too. So your arm scan will look different than anybody else's on the planet. So that's your identifier. So if somebody's trying to impersonate you and they can't replicate your arm scan, that's it. So if we can do that, that would go a long way for sort of some of the fraudulent aspects of things. Then there's also, for every deep fake, there's actually a deep fake filter that you can create, like a way of figuring out if this is a deep fake. And so there will always be that cat and mouse chase that we'll find. But yeah, as long as we're investing in those technologies, we should be fine.
Very good. Deep, that was fascinating. I want to thank you so much for coming by today. And I just have one favor to ask. Since you are building the future infrastructure for our computers, please don't let these computers take us over and kill us in the future.
I will do my best.
All right. Thank you, Deep. Before you head out, if anyone's interested, where can they find anything you're working on, any social media, any websites, anything like that?
Yeah, so my website is Reactive Q, so reactive, the word, then the letter Q.io. And then my Twitter is Deep Neuron, so DeepNeuron. And yeah, thanks for the fantastic questions. It was a great discussion.
Awesome. Yeah, I had a great time. And we'll have to have you back on sometime.
Absolutely.
All right. Well, you have a great night.
Okay, you too, Chris. Take care.